time. This is our group members, Abhinod, Vinay, and Anjanan. We have a project entitled the analysis of technical stack in brake system on automobile. We got an industrial issue from Volkswagen, that is a specific brake noise generated from the brake disc system of virtuous at the beginning.
For this, we compared both the brake disc of Vendo and Virtus, Vendo which is healthy and Virtus which is unhealthy. By comparison, we first started with the dimension based comparison, which is we checked this diameters, thickness and weight of the of both brake discs, and then we compared its design aspects, and then we got into the spectroscopy test. Spectroscopy test means we wanted to compare its material composition. After we did spectroscopy test, what the result we got was the both materials which is used in the brake disc were almost similar. Only negligible changes were there. So as a result, we got that the problem which is occurred in Virtus is not because of the material compositions or the dimensional aspects of the brake disc.
After conducting the spectro test, we got the result that the brake disc of the window material does not have any problem. So that after spectro test, we proceeded with the mechanical setup. So in this mechanical setup, our main objective is to, the first objective is to conduct a sound analysis using this mechanical setup, while the second objective is to conduct a vibrational analysis from the setup and to identify the defects from the braking system. So for that we purchased a lot of parts, second-hand parts of the car Virtus. So this is a Virtus pedal, and in the back side of the pedal we connected the master cylinder, and in that master cylinder we fill the braking oil, and from the master cylinder there's a brake hose which is connected to the braking. This is the caliper assembly of the vehicle, where it is directly connected to the brake disc with the knuckle joint. So we buy all these parts, and it is connected to the engine, while this engine is twin cylinder diesel engine. So after assembling all these parts, the first thing we are doing is that firstly we are starting the engine. So after starting the engine, we press the pedal very hard such that the braking oil from the master cylinder flow through that brake hose, and it reaches the braking caliper. So when the braking oil reaches the braking caliper, it will the piston inside that caliper will exert a force to the braking pads, and both the braking pad will move in this direction to the brake disc, and the brake disc will stop, or its movement will be reduced. Simply the brake will be applied. So during those time the braking noise will arise from the braking system, so that using some sound amplification analyzer, we need to record the braking noise, and after recording the braking noise using this sound amplifier software, we can analyze the frequency sound that is in decibel. We can analyze those graphs
After results from mechanical setup, we did an experiment for analyzing vibration of rotation of window and virtuous brake disc. Initially, our objective is to conduct vibration analysis in our mechanical setup, but later we decided to conduct vibration analysis of a actual braking system mechanically in the Volkswagen showroom. To get accurate values. For that, we took vibrations of first gear in 1000 and 2000 rpm and second gear in 1000 and 2000 rpm, and also both braking in 1000 rpm. For doing this experiment, we use data acquisition system. Data acquisition system converts physical condition into digital form for further storage and analysis.
Start.
It contains magnetic sensors, data acquisition module and case, LabVIEW software and MATLAB software. Magnetic sensors are the magnetic materials which senses the vibrations. Data acquisition module, it supports the analog input for the magnetic sensors and make it compatible for MATLAB.
Start.
LabVIEW, from LabVIEW we can obtain the values of acceleration from amplitude versus
Start.
From LabVIEW we can obtain the values of acceleration from amplitude versus time and amplitude versus frequency graph. From MATLAB we obtain FFT graph of acceleration versus frequency and acceleration versus time graph, and forms weak points. We can identify the defects and the positions.